Welcome friends, welcome to this GATE Fast Track course. We are in the GATE Fast Track course and we were studying strength of materials and we have completed many important topics in this particular course. Yes, we have seen simple stress and strain, elastic constant, deformation of bars, then thermal stress, yes. Then we have seen shear force and bending moment diagram, right? Then we saw bending stress, then we saw shear stress, okay, then we saw torsion, yes, then we had a discussion on columns and combined stresses, yes, and also we discussed the Moore circle for stress and strain, principal stresses, principal strain, yes. So today we are again coming up with a very important topic, that is what? Deflection of beams. There is a very high chance that they are going to ask a question from what? From deflection of beams. Okay, so let us start the deflection of beams. As last class was on what? Columns and combined stresses, yes, and today we'll be focusing on deflection of beams. See, in deflection of beams there are some standard formulas for the standard beams, like simply support beam, yes, and then your cantilever beam, yes, and then standard loading, like the load acting at the midspan, or for the cantilever beams the load acting at the free end, yes. It might be a point load, it might be a UDL, uniformly distributed load, or it might be a varying load or triangular load. So these are known as what? The standard cases for simply support and your cantilever, and most of the questions are from what? From the standard cases. So we'll be seeing those formulas, but the thing is that the formulas are little difficult to remember also. Very easy to remember if you are solving questions, it is very easy to remember also, yes. So there are various methods to find out these formulas, right? So what are the methods? There are methods like your double integration method, yes, then there is your moment area method, right, then there is strain energy method, unit load method. There are many methods, okay, by which you can find out the deflection, okay, and you will get the same expression, okay, you will get the same expression. It's not that if you are applying a different method then the expression will change, yes. So we will be seeing the easiest one, that is the moment area method, and we will try to derive the standard formulas for standard loadings, yes, and then we'll be solving questions on them also. Then we will be solving questions on them, okay. So let us start the lecture, okay. But first of all, let me give you some idea about the moment area method, and then we will be applying them to each case. We'll be applying them to each case, okay. So let us first see what is moment area method, some basics, and then we will be focusing on what? The standard cases. So if we have a beam, okay, I'm not drawing the full beam, okay, I'm drawing a part of the beam, yes, and beam is continuing this side also and this side also, right, and there are 2 points, suppose point B and point A. Then what moment area method suggests, or I can say what is moment area method here? So the moment area method is that the difference of slope, yes, the difference of slope, one second, the difference of slope. So what will be difference of slope? The difference of slope will be the slope at B theta and the slope at A, right? The difference of slope will be equal to what? Will be equal to the area of M by EI diagram, okay, area of M by EI diagram between the points B and A, okay. So it is what? The area of M by EI diagram between the points A and B. We'll understand it better when we apply it. So wait for the questions when we'll apply it. First we add the formula, then we will apply it. And what about the difference of your deflection, okay, the difference of deflections. I can write down what? The deflection at B and deflection at A. The difference of deflection is the moment of area of M by EI diagram. So we will take what? The moment of the area. How we'll take? We'll understand when we'll solve the question. Okay. So the moment of area of M by EI diagram. So we'll take what? The moment of the area. Moment of the area of M by EI diagram. Okay. But when we take moment, the moment has to be taken about some point. So about B we will take. About B we will take. So this is what? This is the two, we can say, conclusions of your moment area method. The difference of slope is area of M by EI diagram. Slope difference is area of the M by EI diagram. Okay. Whereas the difference of deflection is what? It is the moment of area of M by EI diagram. So let us apply this to some standard cases of your simply support beam. Okay. Let us apply to the standard cases of simply support beam, and by there we can find out what? The deflection equations also. We'll find out the deflections equations also. We have to remember the equations. Okay. We have to remember those equations, but in case you forget in the examination, yes, all these things which I am deriving, you should remember these things. But in case if you forget in the examination, then what can do? You can derive them also. In the examination also you can derive them and find out the expression. So simply support beam, suppose this end is pinned. Yes, this is also pinned but roller. And suppose we are applying a point load P at the center. I am applying a point load P at the center. I am applying P or W, whatever. Okay. Can name anything. Suppose I am naming it as P. And it is acting at the midspan, means L by 2, L by 2. L by 2, L by 2. Right. Very good. Now what you do? We have to draw the bending moment diagram. You have to draw the bending moment diagram, right? Yes, you have to draw the bending moment diagram. So if you draw the bending moment diagram, we already know the bending moment diagram of this particular beam, right? We already know the bending moment diagram of this particular beam. It was something like this. Yes, you remember? It was something like this. Yes, it was linear and maximum at the center and then 0 at the supports, right? This was the bending moment diagram. Yes, this was M diagram. This was M diagram. And this maximum value, central value was how much? This was PL by 4, right? It was how much? It was PL upon 4. It was PL upon 4. Now see, this is what? M diagram. This is what? M diagram, bending moment diagram. If I take M by EI diagram, then how I will get M by EI diagram? Just divide it by EI, na? Yes or no? So when I say M by EI diagram, what I will do? I'll just divide the values with what? EI, that's it. Understood? So this is M by EI diagram means what? Whatever is the moment, suppose it was PL by 4, just divide it by EI. So this is what, now it became what? M by EI diagram. M by EI diagram. Very good. Now if you see the deflected shape, due to this load, the beam will deflect like this, right? You see, the beam will deflect like this. Yes. The beam will deflect like this, and if I consider 2 points, suppose this is point B and suppose this is point A. Now see, at A, the slope is what? It is 0 na? Yes. At A, what is happening? The slope is what? The slope is 0. Yes. It is forming something like this, you see, because it is at center na. So it will deflect like this. So slope means what? You draw the tangent and then you draw the tangent and along what? Horizontal we are getting. That means what? Here at A, the slope is 0. At A, the slope is 0. And at B, I am getting some slope, right? At B, I am getting some slope. Okay? At B, I am getting some slope. Okay? Suppose this slope I am telling as theta B. Yes? And here theta A is what? Theta A is 0. Now using that equation, which equation? The equation that, this equation you see, we saw this equation, right? The difference of slope is what? Area of M by EI diagram between B and A. Yes. So here the difference of slope, theta B minus theta A. Theta B minus theta A is what? The area of M by EI diagram. Which area? M by EI diagram between A and B. So between A and B, this is the area of the M by EI diagram, right? You see, this is the area of the M by EI diagram. And this is, by the way, how much? L by 2. And this one was what? 4L by, PL by 4 EI. So it's a triangle, right? It's a triangle. So when I write the difference of slope is area of M by EI diagram between A and B. I'm not writing between A and B. It's obvious because we are finding between A and B. So this is a triangle. Triangle area is what? Half base into height. Half base into what? Height. So what is the slope I am getting at B? Because at A it is 0. So what is the slope I am getting at B? The slope I am getting at B is, you see, PL square by 16 EI. Yes. And by the way, this is what? The slope at the supports. This is the slope we get at what? The supports of a simply support beam when the load is acting where? At the center. When the load is acting where? At the center. Yes, very nice. We got this. Next is, if I am interested to find out this deflection. How to find out deflection? Very easy. You see, I am drawing the deflected shape. Okay, I am drawing the deflected shape. Yes, you see, suppose this was the B point na, and this was the A point. Original beam is like this. This is the B point, this is the A point, right? A point is at center. So this is deflection at A, right? And you see, deflection at B is 0 na, because it is the pinned support. So deflection at B will be what? 0. You see, deflection is pinned support. Now it cannot move. So it is what? 0. And we are getting some deflection for A. Now, the difference of deflection was what? The difference of deflection was the moment of M by EI diagram, right? What was the difference? What is the difference of deflection? The difference of deflection is what? Moment of M by EI diagram. Now, what was the M by EI diagram? I am only drawing between A and B. Yeah? I am only drawing between A and B. This was the M by EI diagram. Na? This was L by 2 and this was PL by 4 EI. Yes. So moment of, you see what was the formula? Moment of area of M by EI diagram about B. So about what we have to find out? About B we have to find out. Yes, one second. So we have to find about B, right? So how we find out the moment of area? You take the centroid. So centroid of a triangle is here, right? Yes. And then we are finding what? About B. We are finding about B. So if you are finding about B, then we have to take this distance, and this distance will be how much? If this is L by 2, this will be 2 by 3 of L by 2. Yes, this is the property of triangle, right? So for a triangle, the centroid is at distance of how much? 2 by 3 of this dimension, and this dimension is L by 2. So 2 by 3 of L by 2. So how much you are getting? You are getting L by 3. So this distance is L by 3. And what is the formula? This is the moment of area of M by EI diagram. M by EI diagram about your B. So how to find out? Very easy. What was the area of M by EI diagram? This was the area, na? You see, this is the area, na? PL square by 16 EI, right? So this is the area. Yes. So PL square by 16 EI, this is the area, and we'll take the distance of the centroid from where? From B. So L by 3. Yes. So we get the expression what? PL cube upon 48 EI. PL cube upon 48 EI. Yes. So this is what? Anyhow, you see at B deflection is 0. So we get the deflection at A how much? We get a negative sign because actually it is downward. So at A it is how much? It is P, if you take only the value wise, it is PL cube by 48 EI. That means what? We can conclude. See, I have derived, but we have to remember the conclusion. That if we have a simply support beam, so we can conclude that if we have a simply support beam, yes, if we have a simply support beam, right, and I am applying a point load at the center, I am applying a point load at the center, okay, I am applying a point load at center, then this will deflect something like this. Then this is going to deflect like this, yes, and at the supports, okay, at the supports, by symmetry we can say that we'll get the same slope. So this is slope at support and this is slope at support, and this I can say is the maximum deflection, right? Below the load or at a point I can say this is the maximum deflection, right? Or I can say this is the central deflection also, right? So the central deflection or the maximum deflection, or I can say this is also the deflection below load, right? This is also the deflection below load. How much we got? We got PL cube by 48 EI. Yes, where this is the P and L is the length, right? You have to remember this, but I have your derived also, so that in the examination if you forget also you can derive within 1 minute also. And the slope at the supports, is how much? It is equal to PL square by 16 EI. PL square by 16 EI. Very good, very nice. Very good, very nice. Let us see the next type of beam. That is UDL. That is what? UDL. So if we have a simply support beam like this, if we have a simply support beam like this, and there is UDL, uniformly distributed load, okay, W suppose, and length is L, right? Now we know the bending moment diagram, right? But I will still draw it for you. If I draw the bending moment diagram, then it is something like this, right? At support you will get what? At support you will get 0, right? And then it is parabolic in shape. Yes, it is parabolic in shape. Yes, it is parabolic in shape. And then, okay, sorry. It is better now. Parabolic in shape. And at center we get how much? At center we get this value as WL square by 8. Now this is your M diagram. But when I take M by EI diagram, so what I have to do? Nothing, just divide this value by EI. That's it, right? So divide this value by what? EI. Very easy. Very nice. Now here also the deflected shape will be something like this, right? Here also the deflected shape will be something like this. So again I will take this point as B and take this point as A. So you see here, at B I will be getting some slope, right? But A I will get what? 0 slope. At A I will get 0 slope. So if I use the equation of moment area method, so the difference of slope is what? The area of M by EI diagram. It is nothing but what? Area of M by EI diagram. Area of M by EI diagram. Now area of M by EI diagram between A and B, right? So I can say this area, right? Only this area. It's a parabolic area, right? It's a parabolic area. Parabolic area is what? It will be 2 by 3 base. It is L by 2, right? Base L by 2 into height. Into height is how much? WL square upon 8 EI. Yes. So how much I am getting this as? You see this 2 will get cancelled. I'll get WL cube by 24 EI. And you see at A slope is 0. So this I am getting the slope at B, or I can say this is the slope at supports. This is the slope at supports. Very easily we can find out if we know the bending moment diagram. We can easily find out, even in the examination also we can find out within seconds actually, right? Within seconds also you can find out this. Very nice. So this slope we got. Now how to get this deflection? So this was the deflected shape, right? This is the original beam, right? And this is the deflected shape, right? This is the deflected shape. This is YA, which is the maximum deflection or central deflection. And here also YB is 0, right? Here also YB is 0. Now we can take YB minus YA is equal to what? Moment of, is equal to what? Moment of area of M by EI diagram, area of M by EI diagram about B. Yes, about what? About B we have to take. Yes, about B we have to take. Yes, about B we have to take. So let me draw this bending moment diagram. So I will draw only between A and B. I will draw only between A and B. Okay, I'll not draw the whole thing. I'll only draw between A and B. Yes, so this is the diagram only bending on A and B. Very good. Nice. Okay. Now area we have already got, right? What was the area? Area we have already got here. You see, area we have already got here. This WL cube by 24 EI. Yes. So area I have already got. WL cube by 24 EI. I have to take the centroid of this area, okay, and then take its distance from B, right? Then take its distance from B. So this is the centroid. So I have to get this length. How to find out? For that, I'll give some points. You see, if we have a curve like this, the triangle, if we have a curve like this, if we have a curve like this, yes, now this curve can be any curve, right? It can be 2 degree, 3 degree, right? It can be 2 degree, 3 degree, right? Suppose I am telling n degree. I am telling what? N degree. If it is an n degree curve, you can see there are two areas, right? This is one area, this is second area, right? So suppose this is the second area, this is the first area, right? So remember that area 1 is equal to 1 by n plus 1 into, this is the base and this is the height. So B into H. And area 2 is what? Area 2 is n by n plus 1 into B into H. N by n plus 1 into B into H. Yes, remember this. And therefore, if you see, if I apply for a parabolic curve, right? If I apply this to a parabolic curve, right? If I apply this to a 2 degree curve, 2 degree means what? If it is a parabolic curve, right? Then this area becomes what? You see, n by n plus 1. So here n is what? 2, right? So what it becomes? This area becomes what? This area is n by n plus 1, 2 by 3 B into H. Yes. And this area becomes what? You see, this area becomes 1 by your n plus 1, right? You see, 1 by n plus 1. So this area becomes 1 by 3 into B into H. Yes, easy. Yes. And if you add them, you see, if you add them, this will become the area of a rectangle, right? 2 by 3 BH, 1 by 3 BH, it is what? BH, right? Understood? So this is the areas. Now coming to the centroid. Okay, coming to the centroid. The centroid is here, right? The centroid is here. Okay. So remember, here centroid is here. So remember, from this end, if I am trying to find out this distance is what? Remember, it is n plus 3 by 2 n plus 2 into B. Yes, n plus 3 by 2 n plus 2 into B. Yes. Now if I want to find out for parabolic area, then what will happen? This length will be how much? N plus 3, n is 2. So 2 plus 3 divided by 2, then n plus 2, 2 plus 2 is 4 into B. How much I am getting? 5B by 8. Understood? We get how much? 5B by 8. So this dimension is how much? 5B by 8. Now I can apply now this to our equation, right? So this dimension is how much? L by 2 here, right? Here it is L by 2. So what will be this centroid distance from here? Comparing, you see, if you compare 5B by 8, yes, if you compare 5B by 8, so what it will be? This will be 5 by 8. In place of B, here it is how much? L by 2. So this becomes how much? 5L by 16, right? So then what I will do? I will multiply this distance, right? Because I am finding the moment. So it will be 5L by 16. So how much you are getting? You see, 5 W L to the power 4 divided by what? 384 EI. Understood how we found out this? Yes, very easy. Yes, first we got the area. Yes, now this area was what? If you see, this area was 2 by 3 into B into H. So 2 by 3 into B into H we did, and we got this slope, right? Area of the M by EI diagram, right? And then when I'm finding the difference of the deflection, then I took what? Moment of M by EI diagram, and therefore what I did, I have to find this distance. How I got this distance? By this formula, and for applying for parabola it was 5b by 8. Yes, so 5b by 8. Yes, here b is how much? L by 2, so it become how much? 5L by 16. Understood? Next. So now, so here B is 0. So why I will get negative? Because it is downward deflection. Numerically it is how much? It is 5WL4 by 384 EI. Yes. Now you have to remember these formulas. Okay. Anyhow, directly they will ask you questions, will solve questions also. But in case you forget, then always you can find out, right? Yes, you can always find out. Yes. So now let us summarize what we have studied till now for this thing. Yes. So now I can say that if we have a beam with what? Simply support beam with what? With a UDL. With a UDL. With a UDL. Then I can say that here at the supports, by symmetry I can say that I will get the same slope. Yes. And what slope I got? It was WL cube by 24 EI. We derived also, right? We derived also. So this was W, right? And this was the length. And this central deflection, right? Or the maximum deflection here, I can say the central deflection, or I can say the maximum deflection is what? It is 5WL4 by 384 EI. Yes. And how to find out, that also we saw, right? How to find out, that also we saw. Now time to solve some questions. Okay. Now it's time to solve some questions based on this. Okay. In your GATE examination, most of the questions are very straightforward. Yes, they're very straightforward. But if you don't know the formulas, okay, or if you forget the formulas, then it becomes little difficult to solve the questions. So let us solve some questions to understand that what kind of questions they can ask you in the examination. Okay. Let us start with a very simple question. Let us start with a very simple question. Okay. Suppose we have a simply support beam like this. Yes. Simply support beam like this. Okay. And then it has two loadings. One is a UDL. Okay. One is a UDL, and we have a point load also. We have a UDL and also we have a point load acting at the midspan. Okay. The UDL value is 5 kilonewton per meter. Yes. And this load is 8 kilonewton. Okay. This load is what? Central load is what? 8 kilonewton. And the span is given 10 meter. It is given as 10 meter. The span is given 10 meter. And the EI is given to us as 20 into 10 to the power 6 Newton meter square. So this information is given to us. Okay. What is asked? It is asked to find deflection below point load. Okay, deflection below point load. In mm it is asked to find out. That's a very easy question. If you know the things, it's very easy. So this is what? It is acting at the midspan. So 5 meter, 5 meter. Okay, I'm doing just 5 meters. Obviously that is 5 meter only. So what to do? Very easy. Here we can superimpose the deflections. Yes, we can find out the deflection due to that 8 kilonewton and deflection due to this 5 kilonewton per meter, and then add them up, right? So I can say here, this deflection which I am finding, I can say I can find out due to this 8 kilonewton load, yes, and then plus deflection due to what? This 5 kilonewton per meter load, right? Now what are the formulas we use? The formulas, and therefore now the formulas are important. You should know the formula. So this becomes what? Your PL cube by 48 EI, right? Yes, and this was what? It was 5WL to the power 4 divided by what? 384 EI. Yes. Now see, we have to be very careful about the what? We have to be very careful about the units. Yes, you have to be very careful about the units. So what you do? It is given Newton meter square. Now, let me put everything in Newton and meter. That will be better, right? Let us put everything in Newton meter. So when I'm solving this question, the deflection, first one P is given 8 kilonewton. So let me put in Newton. So 8 kilonewton converts to Newton. 8, then PL square. L is 10. Yes. PL cube, sorry, PL cube. So 10 cube. I'm putting everything in Newton and meter. Divided by what? Your 48 EI. 48 EI. And EI is what? Actually 20 10 to the power 6, or I can say 2 in 10 to the power 7, right? Now see the units carefully. This is Newton meter cube, right? Because this is Newton and this is meter cube. And this was what? EI was Newton meter square. So I will be getting this in meter, right? I'll be getting this in meter. If I want in mm, what I will do? I'll multiply 10 to the power 3, so I'll get in mm. Similarly, the second one is 5 W. W is what? 5 only, but it is kilonewton per meter. So what I will do? I'll convert into Newton per meter. So this much Newton per meter into L to the power 4 divided by 384 and then EI. Now you see, this is Newton per meter and then meter to the power 4 divided by Newton meter square. So Newton get cancelled. This is meter cube and I get in meter. So again, if I want in mm, I'll multiply what? 1000. I'll multiply what? 1000. So multiplied by 1000 mm. Yes. So everything now I'll get in what? Mm. So find out this answer and give me the value. Okay, I'll also calculate, but you calculate, add them up and give me the answer, final answer. First one, there will be so many cancellation, right? You see, this will get cancelled. This is 2 actually. So it becomes 800 divided by 48 divided by 2. This is actually 8.33, right? Then the next one, if you see, this will get cancelled entirely. So 25 into 10 to the power 3 divided by 384 further divided by 2, 32.55. 32.55. Yes. So how much I am getting? If I add both of them, I am getting 40.88 mm. 40.88 mm. Yes, 40.88 mm. Understood? So this kind of straightforward questions will be also asked. Yes, and therefore it is very important to remember these basic equations, right? Before targeting, very high things, okay? Before targeting to reach the moon, first of all, you should know the basic equations. If the basic equations, they will ask a lot of questions, and people get confused in the basic equations only. Yes. So this is one type of question. Directly they can ask you values. They can ask you another type of question, another very interesting type of question they can ask you is comparing. Is what? They will ask you to compare the deflection of two beams and find out the ratio of their deflections. Suppose there are two beams. Suppose there are two simply support beams. Okay. One simply support beam is like this. Okay. Suppose this is having 2 meter of length and having a loading of W, right? Another one is also a simply support beam, but it is having a length of your 4 meter. It is having a length of what? 4 meter. Okay. It is also loaded with the same W. It is also loaded with the same W. Yes. But its length is 4 meter. Its length is 4 meter. Okay. So, suppose I am giving this as beam, suppose beam A, and this is beam B. This is suppose beam B, right? And this beam has a cross section, square cross section. A has a square cross section whose dimensions are 40 mm. So it has a square cross section, dimensions how much? 40 mm. Whereas B is also having a square cross section. B is also having a square cross section, but it is having what? 50 mm. It is having what? 50 mm. Yes. Now it is asked to find out the ratio of maximum deflections of A and B beam. Such kind of questions are very hit in your GATE exam. Such kind of questions they ask you a lot in the GATE exam, and therefore you should be solving this kind of questions. So first you try this and then I will answer you. W is same in both cases, length is different and same material, so E will be same, right? Same, nothing, if not mentioned also you can assume same material. If it is not mentioned, then what you will do? Same material means same E. But cross section is different, so I won't be same, right? So you try this first and then I will solve it for you. Okay, let us solve this. Very easy actually. It's very easy. You see here, if I see for the beam, I'm just writing A and B, yeah. Then the maximum deflection is a simply support and UDL, so I can say this will be the formula, right? This will be the formula for A, yes, and B. Right? Now material is same. Material is same means what? E gets cancelled, 384 get cancelled, 5 get cancelled, loading is same, yes. So this becomes, you see, LA by LB whole square, right? LA by LB whole square. Then what? IB by IA to the power 4. Sorry, IA to the power this whole square, not 4 actually, this is 4. Yes, this is the thing we get, right? And this. Now for a square cross section, what is your, for a square cross section, I can say the I will be what? The side length, suppose A, yes, to the power 4 divided by 12. Similarly, for the A1 also, the side length to the power 4 divided by 12, right? Yes, because for a square section of side A length, what is the I? It is A to the power 4 divided by 12. Yes. Easy, you see. So this becomes what? LA by LB. So 2 by 4. So 2 by 4 to the power 4, right? Then what is AB? AB is, for B it is 50, side length is 50, for A it is 40. So I can say this is 50 by 40 to the power 4, right? So we can find out this. Actually this becomes what? 100 by, this becomes actually 100 by 160 to the power 4, right? Yes, 100 by 160 to the power 4 actually. Yes, now you can easily find out this. Yes, remember in GATE they won't be asking you lengthy questions. Okay, so when you're preparing for GATE, try to solve more conceptual, yes, and more short questions. But concept will be same, heavy only, but length won't be that much. I'm getting 0.153. This ratio are getting how much? Yes, 0.1, if we to be more precise, 1526, or I can say, let us solve another type of question which they ask. Sorry. Here also we have two beams. As I told, there will be a lot of questions on comparison. So here also we have two beams. Suppose this is beam 1 or beam A, suppose. And here we have a, in fact this is the previous year GATE question only. This is a previous year GATE question. So this is beam A. Yes. And this length is 4 meter. Okay. Then we have another beam like this. It is 2 meter. And we have a point load of 120 acting at the center. Right. So this is 2 meter. This is 1 meter, 1 meter. And this is beam number, this is beam B. This is a GATE question actually. So what is asked here? To find out the maximum deflection of A and ratio to B. Find out, very easy question. What is this? Very easy question. You should be able to solve within 1 minute actually. Please solve this. What is the answer to this? One. Very good. Easy actually. Very easy. One. Yes. Yes. So now you see how it is 1. If I take this for A, it is what? 5 WL4 to the divided by 384 EI, right? And for this one, it is PL3 by 48 EI. See, nothing is mentioned in the question means what? If nothing is mentioned, material is same, cross section is same. Okay, assume that. Okay, then length is not same, but length is not same, so I'll put the values. 5, there W is 6, right? Put everything in kilonewton and meter. L is 4, so 4 to the power 4 divided by 384, and then P is how much? 120, and L is here 2 meter, so 2 cube, right? And this is 48, right? So if you are finding it, you're getting how much? You're getting actually, let me just cross check it. Is it 1 or not? Most of you are found out correctly only. Let us just cross check it. Or if you want to solve, this is 30. So 4, this is 4 cube. 4 cube is what? 64. And this is 8. So this get cancelled. This is 8. Then if you take it, 8. So 4, 64, 48, 48, 48, 1. Without calculator also you can find out, right? Okay. Another type of question which they ask in the examination. Okay. We have a simply support beam. Okay. We have a simply support beam. Okay. Whose length is how much? 4 meter. Yes. And then the slope at supports is given. So this slope at support is given as 1 degree. It is given how much? 1 degree. Yes, it is given how much? 1 degree. Okay. Now we have to find out what? The maximum deflection here. We have to find out what? The maximum deflection in mm. Okay. And we have a, let us take this as point load. Let us not take this as this. Let us take this as a point load acting at the center. And the load is also not given. Okay, the load is also not given. Only P is given. Only P is given. Now how to solve this type of question? It's very easy actually. I'll tell you how. You see, what was the slope value? It was PL square by 16 EI, right? And what was this maximum deflection? It was actually equal to PL cube by 48 EI. Now see, if you take this ratio of slope and maximum deflection, you will get what? If you see, or let us take maximum deflection by slope. If I take the ratio of here, maximum deflection by slope at supports, you will be getting what? 48 actually, this is not 4, 48. If you take this ratio, you will be getting L by 3, na? You see? Yes, you will be getting L by 3. How? You see, this is PL cube by 48 EI. Yes. And then PL square by 16 EI. So So you see PL square and L remains, and then it is 3. So L by 3. Now you can solve this question so fast in the examination, right? So from here I can say what is the maximum deflection? It is simply, you see, L by 3 into theta, right? Yes, L by 3 into theta. Very fast you can solve. Yes. But now thing is that it is given in what? Degree. Whereas the formula gives the answer always in radian. So this is always in radian. So if it is given in degree, it is your job to convert into what? Radian, right? So this is L is 4 meter. I have to find in mm, so I'll convert into mm. So 4000 divided by 3. It is given 1 degree. 1 degree is how much radian? Pi by 180 radian. So I express the theta in radian and then multiply by L by 3. It is in mm. So I'll get the answer. You see, so fast we can solve in the examination. We have to understand in the GATE exam what type of questions they are asking, okay? Otherwise, we will be just hovering here and there, but the answer will be very short and smart people will be able to solve the answer very fast way, okay? How much are you getting? 23.27 mm. Yes. So if you just know this thing, right? If you just know this thing, then you can solve so many questions, right? So what they do in the examination, you know, on this simply support beam. So suppose I am telling this for UDL and suppose point load. Yes. So here if you see, this slope at supports by the maximum deflection is what? This we got as L by 3, right? Now for this thing, how much I will get? This by your maximum deflection. If you see, this is WL, sorry, ulta, na? Sorry. Reverse. Y max by theta S. This is, you see, 5WL4 by 384 EI divided by slope was what? WL cube by 24 EI, right? So EI get cancelled, WW get cancelled, L cube, this remains L, and then if I divide it by 24, I'll get 16, I think, yes, 16. So I get what? 5L by 16, right? So this is what? The maximum deflection by theta S. So this is another important formula, and they can ask you many questions on this, right? What they will do, you know? They will do, you know, in one question, they will give length and then maximum deflection, ask you what? Slope at supports. And this slope in supports will be in radian, remember, it should be in radian, right? In another question, they will give you the slope at supports and length and find out what? Maximum deflection. Or in some question, they might give you the maximum deflection and the slope and ask you what? Find the length. And if you know this conclusion, then you will be able to solve very fast in the examination, right? Yes or no? Otherwise, you will start doing research in the examination. Other students who know these things, they will be solving very fast. Yes, they will be solving the questions within, 1.5 minute. Okay, there is no time in the examination that you are deriving it, then so that much time is not there. Yes, and similarly here maximum deflection by theta S is nothing but what? L by 3. So here also they can frame so many questions. So all these standard results which I am deriving and giving you are very important. They will frame lot of questions on this. So this was on what? Your simply support beams. Let us go to cantilever beams now, right? Let us see something on what? Cantilever beams. Yes, cantilever beams. So cantilever beams, first we'll start with what? I'll start with your a moment acting at one end. Okay, suppose there is a moment acting at one end. If we have a bending moment M acting on one end, right? Then what is the bending moment diagram? Everywhere it will be M only, na? So bending moment diagram will be what? It will be like this. Constant bending moment M. Because if you see anywhere you cut a section, it will be same, na? Bending moment will be same, na? Equal to M, na? So bending moment will be same here at any section. So it will be M value. And this is length. Yes. And the deflected shape will be what? The deflected shape will be something like this, right? Sorry. Okay. If I take the reverse, suppose the bending moment is acting like this. Okay. So I'll get M only with a negative sign actually. Okay. So now you see the deflected shape will be something like this. You see the deflected shape will be something like this. Yes. And suppose this I am taking this fixed end I am supposed taking as the A point, and the free end I am taking as the B point. Now see, at the fixed end the theta also will be 0 and deflection also will be 0. Now at the free end you can see that if you draw a tangent there will be some slope, right? So this is the slope at B, or I can say the slope at free end, and this is the deflection at the free end, or I can say the deflection of point B, right? And this is the sorry, and this is the moment diagram, bending moment diagram. But I need what? M by EI diagram. So what I will do? I'll divide by EI. Game over. Very easy. Now if I use the formula, the difference of deflection slopes is what? Area of M by EI diagram. What is the area? ML by EI, right? If you only take the value. So ML upon EI, right? It's a rectangular area. M by EI into L. ML by EI. Game over, right? It is anyhow 0. So slope is what? ML upon EI. So here, this is the slope at free end. Okay, this is the slope at free end. Okay, now if I take the difference of deflection here, that will be what? That is the moment of the area of EI diagram. So this is the area. Now if I take the moment about which point? B point only, na? So about B point I will take. So this is the area and it's a rectangular area. So this will be the center. Yes. And this will be how much? L by 2, right? Because I'm finding from B. Rectangular area, centroid will be here. And from B it is at L by 2. So when I take the moment, so moment of the area about B, so L by 2 giving me what? ML square by 2 EI. Very easy, I derived, right? Very easy. So I can say that this is the deflection at the free end. Why? Because you see YA is anyhow 0, right? So this is the deflection at the free end. Very easy, ML square by 2 EI, ML by, if you know the bending moment diagram, you can find in seconds, right? Very good. Let us see the next one. The next one is what? When the point load is acting. When we have a point load acting. Okay. When we have point load acting. Again, I will choose this as point A. So slope is 0 and deflection is 0 here. And the deflected shape will be something like this. Okay. Same thing. If I apply a point load also, it will be like this only, right? If I apply a point load, suppose P at the free end. Very good. So here I will get some slope. Yes, if I draw a tangent, I'll get a slope theta B. This is the slope at the free end. And this will be what? This will be the deflection at the free end. Now how to find it? Very easy. I'll draw the bending moment diagram. If I draw the bending moment diagram, yes, what is the bending moment diagram here? Very easy. It is triangular, na? Yes, because anywhere you cut a section, then what happens at x distance? P into x. So P into x is the bending moment, right? Sorry. So P into x is the bending moment, right? So it is linear, right? Yes. And at this end, bending moment will be how much? P into L, right? It will be how much? P into L. Yes, this is the bending moment diagram. Yes. So now when I find out the difference of slope theta b minus theta a is equal to what? That is the area of m by ei diagram. So if I take the m by ei diagram, so what I will do, this make it pl by ei. Yes. So what is the area of this? This is a triangle. So half base into height, pl by ei, that is equal to pl square by 2ei. Yes, and this is anyhow 0. So from here I can say the slope at the free end, how much I get due to this point load, pl square by 2ei. Very easy, right? Similarly, if I take the difference of the deflections, this is the moment of the area. Area we got pl square by 2ei. If I take the moment of this area about point B is here. So first of all, I have to take the centroid of this. Centroid of a triangle is at how much distance? At from B distance, it will be at a distance of 2l by 3. Yes, because this is L, this will be 2l by 3. So this is the centroid, and from B it is at 2l by 3. So if I take the moment of this area about B, so it will be 2l by 3, giving me how much? PL cube upon 3ei. Why? Because you see this 2 will get cancelled, right? This 2 will get cancelled. So easily I derived for what? This is what? I can say again, this is 0. So I can say the y at free end, the deflection at free end, we derived for this point load. Very easy. So earlier case, ml by ei, ml square by 2ei, if only a bending, only a moment is acting. Here, pl square by 2i, pl cube by 3i. Yes, easy. Next we'll see is a UDL. Let us see UDL na. So if we have a UDL like this, even if there is UDL, doesn't change some things like theta at A end will be again 0 only. It is fixed now, it will be 0 only. And deflection also will be 0. And the deflected shape will be something like this. Yes, deflected shape will be something like this. And again at this point B, I'll get the deflection, and this is the deflection at the free end. And again at this point, I'll get some slope. And that is what? I can say that is the slope of the free end. Now first I have to draw the bending moment diagram. If you remember, this is what? You see, here load is, UDL means constant. If load is constant, shear force will be linear, bending moment will be parabolic here, right? So bending moment diagram is what? It is something like this, right? The bending moment diagram is something like this. It is parabolic, right? It is parabolic like this. And what is the value here? How to find out the bending moment at the fixed end? Very easy. It is W, total load will be how much? W into L, it will be acting at L by 2. So if I find out the moment about this point, WL into L by 2, it will be WL square by 2. This is the bending moment at the fixed end. But we have to take what? M by EI diagram. So I will take divide by EI. And this is what? L. And this is parabolic distribution. This is what? parabolic distribution. Okay, very good. So this I got is the bending moment diagram, or M by EI diagram in fact. Yes. So when I take here the difference of slopes, means what? If I take here theta B minus theta A, it is area of this M by EI diagram. Now tell me, I will use here 1 by 3 or 2 by 3 formula for parabolic. Here I will use 1 by 3 or 2 by 3. Tell me. This is looking like what? 1 by 3 BH or 2 by 3 BH? It is 1 by 3. I don't know why nobody is answering. Okay. Okay. It is 1 by 3. Base is how much? L. And then W L square by 2 EI. See, this is something like this, na? So this is 1 by 3 BH, na? Obviously, na? This should be less, na? And this will be obviously 2 by 3 BH, right? See, we have seen this one. So can't you relate? Huh? Common sense, na? This is 1 by 3 BH and this is 2 by 3 BH. Little aptitude, na? Logical reasoning. Yes. So this is what? 1 by 3 BH. Yes, this is what? 1 by 3 BH. So I can use what? You see? I can use what? This. So how much I am getting this value? I am getting WL³ by 6 EI. Yes. And theta A is 0. So I can say this is the theta at the free end when we have a UDL. WL³ by 6 EI. Yes. WL³ by 6 EI. Now coming to the deflection. YB minus YA. Yes, is equal to moment of the area. Area we have already got. Moment of the area about what? About B. So I have to take the centroid here. I have to take the centroid and I have to find out the distance of this centroid from what? From this point. Okay. From this point, from B point, I have to find out the centroid. Then only I can find out what? The moment about B. Now how to find out this centroid? I will tell you. Coming back to this diagram. Yes. So if you see this first area, the centroid suppose is somewhere here. The centroid suppose is somewhere here. Then remember that this value is how much? This value is n plus 1 by n plus 2 into B. It is what? N plus 1 by n plus 2 into B. So for a parabolic area, what will happen? For a parabolic area, this distance will be how much? This distance will be, you see, n is 2, 2 plus 1, 3, then n plus 2, 4, 3 by 4b. Understood? It is what? 3 by 4b. Remember, for this first area, I'll have the centroid a distance of how much? 3 by 4b. Now, if you see, this area is like this, right? And I'm telling that from this end, it is what? This is 3 by 4b from this end, right? If you see our area is like this, right? The bending diagram is like this. So centroid will be here. So by symmetry, I can say, or we can say it's a mirror image, right? So from this end, it will be how much? Same 3 by 4 into b. Able to relate these two diagrams, right? Able to read the two diagrams? Yes. So it is 3 by 4 into base. It is 3 by 4 into base for a parabola. Yes. So coming back to our diagram. Yes. So it is 3 by 4 of the base. Base is L. So this becomes what? 3 by 4 into L. Yes. So I'll multiply here what? 3 by 4L. So this is what? The moment of the area about point B. So this get cancelled. I get a 2 and I get what? Anyhow this is 0. So I can say the deflection at the free end, how much I am getting? I am getting WL4 by 8 EI. Easy to remember, right? So in case of any confusions, you can always, find out in a very fast manner, right? Yes, so this is for what? Your UDL. Last one is for a triangular load or varying load, I can say, right? Last one is for a triangular load or a varying load. Are that is fine. Again the same thing. Theta A is 0 here and YA is 0 here. And again the deflected shape will be like this. Yes. Again the deflected shape will be like this. Yes, very good. And again I can say that at this point B, this will be the YB, and then if I draw a tangent, then this will be the slope. And loading is what? Loading is uniform, this varying distributed load, something like this. Varying distributed load, something like this. Yes, and this value is W here. This maximum value is what? W here. Okay, this is W. And this is L obviously. Now the bending moment shape will be what? Tell me. What will be the bending moment shape? Because the load is linear. Load is linear. What will be the bending moment shape? Any idea? What will be the bending moment shape? Hare? Nobody is telling? I will tell them. The bending moment shape is what? It will be cubic. It will be cubic. Why? Because the load is linear. Very good. Some people have answered. The load is linear. So the shear force will be parabolic and bending moment will be cubic. So it will look like parabolic only. See, if I draw, then it will look like parabolic only. But it is what? It is cubic. It is cubic. Now if I want to find out the bending moment at the support, is very easy. How to find out the bending moment at support? You see, this total load will be what? This total load will be WL by 2, because triangular load. So WL and this is triangle, na? So half base into height. WL half WL by 2, and this will be acting at how much distance? L by 3. So what is the bending moment at the support? WL by 2 into L by 3. This is WL square. WL square by 6. And obviously you have to find out what? You have to find out what? The M by EI diagram. So it will be what? WL square by 6 EI. It will be WL square by 6 EI. Yes, WL square by 6 EI. Earlier case was what? WL square by 2 EI, right? It was WL square by 2 EI because WL acting at L by 2. Here it was WL by 2 acting at L by 3, right? So WL square by 6 and M by EI diagram. Yes, very good. Now, if I want to find out the difference of slope here, theta B minus theta A, it is the area of this diagram. Now this is not a parabolic, right? So I cannot use that 1 by 3 formula. I cannot use the 1 by 3 formula. If you remember, you see what I have told you, see that this area is what? 1 by n plus 1 into BH. Yes. And therefore, when it was parabolic 2 degree, so what was happening? It was becoming 1 by 3 into BH. But when it is cubic 3 degree, what will be this area? This area will be, you see, 1 by 4 into BH, right? Understood? Yes. So in the earlier case, you see, in the, sorry, where it went? When it was parabolic, the area I took was, you see, 1 by 3 BH, right? The area I took was 1 by 3 BH when it was parabolic. Yes. When it is cubic, I will take what? 1 by 4 into B into H. Understood everyone why we took B in 1 by 4? Because of this formula which I have told here, right? Small things are very important to remember these equations, otherwise where it went? See, 1 by n plus 1 BH for parabolic 2 degree, 1 by 2 plus 1 for 3 degree, 3 plus 1, so 1 by 4 into BH. Yes, very good. So I can write down this as this one, and here is 0. So I can say what is the slope at the free end? Very easy. It is WL³ by 24 EI. Yes, WL³ by 24 EI. Very easy. Yes. Now coming to difference of your deflection, I have to take the moment of this. I have to take the moment of this about B. So I have to find out the centroid. I have to find out the centroid, right? And take the distance from what? From B, this distance. Now see, in the earlier case, it was 3 by 4 L, right? It was 3 by 4 L. Why? Actually, the formula was what? Actually, the formula was n plus 1 by n plus 2 into L, right? So when I was putting n is equal to 2 for parabolic, I was getting what? 2 plus 1, 3, 2 plus 2, 4. But in this case, if I put the formula n plus 1 by n plus 2 into your base is actually L, so here also is L. So it will be what? N plus 1. N is how much? 3 here. So it becomes what? 4 by 5L. Easy. Yes, 4 by 5L. So I'll multiply 4 by 5L here. So it becomes what? You see, WL4 by 30 EI. That's it. Everything we derived. Yes. And these two were a little similar, but difference was what? You see, it was cubic. So area was different. Yes. And also the distance of the centroid was different. So if I conclude here, then we'll solve some questions. If I conclude here, so slope at free end, right? And then deflection at free end, right? So everywhere length is L, and suppose M moment is acting. So here M moment is acting, here point load P is acting, right? Here UDL is acting, and then here last one is linearly varying load. See, they can ask you they can ask many complicated things also, but my aim is that we should first cover all the things which are very basic and which are very frequently asked. So if you have not covered them, you are trying to do something very crazy stuff. So in examination, they will ask you the simple things, and then We forget. So it is what? It was ml by EI. I have already derived it, so I am just writing the conclusions. Here it is ml square by 2 EI. Okay. Here it was PL square by 2 EI. Yes. Here it was PL cube by 3 EI. Right. Here it was WL cube by 6 EI. Yes. Here it was WL4 by 8 EI. Yes. Here it was WL cube by 24 EI. Yes. Here it is WL4 by 30 EI. Yes. So all these conclusions are very important. Yes. These are the basic things. Let us solve some questions now. Okay. Let us solve some questions now. Already for simply support beam I have solved many questions. Let us solve some questions for your this. Here also similar questions are asked actually. Okay, here also similar questions are asked. Let us start with some simple one. Okay, like the one question we solved for what? For simply support also. Suppose we have a cantilever beam here, sorry, cantilever beam, and we have a UDL given, which value is not given. Yes, it is 3 meter, and it is written that the slope at the free end is 1 degree. And it is asked to find out the deflection at free end in mm. Yes, deflection at free end in mm. This similar question we solved for cantilever for simply support also, right? What I told, very easy. What you do here, you see, what you do here, this is UDL. Na? I have already told that you can take the ratio. What is the y at free end and theta and free end ratio for this UDL? If you see, this was WL4 by 8 EI, yes, and this was WL cube by 6 EI. So EI get cancelled, WW get cancelled. The 6 goes up and I get what? 6 by 8 or 3 by 4L, right? Very easy. So now you see deflection at free end, you can easily find out. Yes, normally people what they do, they do little long approach. What they do, from this free end, they find out W, they have length, they find W by EI, then put here. It takes too much time, right? Not required, you can be smart. So from here I can say the Y at free end will be what? It is 3 by 4L, the slope at free end. So the length is anyhow given 3 by 4. What is the length given? Length is given as 3 meter. So I'll use 3000 mm because I want to find in mm actually. And as I told, always express the theta in what? In radian, right? It should be always in radian. In radian, it will be how much? Pi by 180 radian. So find out this answer. You can see this type of questions are asked, and 2 mark. This will be 2 mark question. Okay, but you can answer it within 1 minute actually if you know the things. So 3 into 3000 divided by 4 into pi divided by 180. $39.27. Yes, 39.27. And these questions are very common in your GATE, EAC, any other exam. These are the questions which they frequently ask. These are the questions which they frequently ask in the examination. Okay. So this type of, therefore I have derived those formulas and I am solving this question. Another question you solve and tell me. So here we have a cantilever beam only. Now UDL is acting like this. It is given that the y at free end is given to us as 15 mm, and the theta at free end, slope at free end, is given to us as 0.02 radian. Okay. Find length of the beam in meter. Very easy question. Find length of beam in meter. Come on, find out. Easy question. Be careful of units. Be careful of units. Don't commit mistake in units. Huh? Be careful of units. Arey, why you are taking so much of time? Huh? Just now we saw, right? Just now we saw, right? That for this case, y free by theta free is equal to 3 by 4 of L, right? Yes. So from here, this is 15 mm. So I'll put 15 mm. And theta anyhow I'll put in radian only, it's given in radian only. So 0.02 radian. Okay. That is equal to 3 by 4 L. So from here I will get the L in mm because this is in mm na. So if I find out here, if we use this thing, then I'll get in mm only. Right. So it is, you see, 15 into 4 divided by 3 divided by 0.02. I'm getting 1000 mm, right? I'm getting what? 1000 mm, which is, by the way, how much? That is equal to 1 meter. That is equal to 1 meter, right? Therefore, this equation is very important. They can ask you many questions, right? There are 3 things. They can ask you many questions. And therefore, in this deflection conclusion, right? In this deflection conclusion, along with theta free and y free, we can remember this equation also. What? That what is the value of y free by theta free, right? What is this ratio? Because they can ask questions where we can use the ratio and they can frame questions like this. The same thing they framed for what? Similar questions were framed for simply support beam and they can frame for this also, right? So what is this ratio for the first one? This ratio, if you see, it is actually L by 2, right? It is actually L by 2. Yes, L by 2 if you take the ratio. If you take the ratio here, you will get actually 2L by 3, right? If you take ratio here, you will get 3L by 4. And if you take ratio here, you will get what? 4L by 5. So easy to remember, you see. The ratios are easy to remember also, because if you see what is L by 2, L by 2 is actually 1 L by 2, right? So you can see 1 by 2, 2 by 3, 3 by 4, 4 by 5, right? So based on this, yes, based on this, they can frame questions on this, on this, on this, on this. So many questions they can frame, right? Yes. Example I just gave now. This kind of questions they can frame. Yes. Example I gave. You see this question and this question example I gave. Here we did for what? Here we did for only UDL, but they can do the same thing for what? They can do the same thing for your other things also, like they can do for point load, they can do for varying load, they can do the same thing. Okay. Now next type of questions are asked from propped cantilever. Okay. They ask questions from propped cantilever. Now what is this propped cantilever and what type of questions they can ask? Okay. And we can solve the propped cantilever questions actually, okay, using cantilever thing only. How? You see. Propped cantilever is what? We have a cantilever beam whose free end is actually pinned here. Yes. So free end is pinned here. Yes. So this is what a propped cantilever. Okay. Now in this what they ask is to find out the reaction here. So how to find? Very easy. You see. Suppose we have a UDL acting like this W and it is asked to find out the reaction here. This is known as the propped end. This is known as what? The propped end. It's a propped cantilever. This is a propped end and it asks to find out the reaction here. How to find out? Very easy actually. Yes. What we can do is that we can take two combinations. We can take that, you know, there is a UDL acting. Yes. There is a, there is the UDL acting like this. Yes. There is a UDL acting like this, and due to this UDL, this beam should deflect like this, right? Yes, this beam should deflect like this. And then there is a reaction acting like this, upwards, right? So due to this reaction, what will happen? Due to this reaction, yes, that beam should deflect like this actually, right? Yes, the beam should deflect like this. And this is the deflection. But the thing is that the end is what? It is pinned. That means net deflection should be 0 here, right? If net deflection is 0, this downward should be equal to this upward, na? Right? Yes. This downward should be equal to the upward, na? So now what is this downward deflection? This we have got. This is WL4 by 8 EI. It is what? WL4 by 8 EI. Yes, it is WL4 by 8 EI. Yes, we have found out this value. Yes, this is the UDL. And this is what? This is a point load, right? This is a point load. So due to point load, PL cube by 3 EI, here it will be RL cube by 3 EI. Yes, RL cube by 3I. So these two has to be same. These two has to be same. Then only what will happen? Here, the net deflection should be 0. So I can equate them WL to the power 4 divided by 8 EI is equal to what? Is equal to RL cube upon 3 EI. Yes, so what will happen? You see, this get cancelled, L, EI get cancelled, I get R is equal to 3WL upon 8. Yes, so we can find out the reaction at the propped end using the concept of what? Using the concept of the deflection, that you know that this deflection should be same, and from there we found out the reaction. Yes, so remember this, okay? I have already found out this, but you can remember this also. They can frame a very simple question like this. You see, what they can frame is, suppose they can do like this. You see, suppose there a UDL is given like this. Yes, this is the propped end, and suppose I am telling that this is 6 kilonewton per meter and this is 4 meter. Okay, this is the A end, suppose, and this is the B end. It is asked to find out the reaction at A, actually it is asked. Okay, reaction at A. That is very easy actually. How? You see, we can find out the reaction at B, right? What will be the reaction at B? I have just derived the formula. 3WL by 8. So it is 3, W is 6, L is 4 divided by 8. So this becomes how much? 9. So it is what? 9 kilonewton. Yes. Now total load is how much? Total load is 24, na? Yes. 6 into 4, 24. So total load is 24. Here it is 9. So here it has to be how much? 15 kilonewton, right? It has to be how much? 15 kilonewton. So reaction at A is how much? It is 15 kilonewton. So always they might not ask you the reaction at the propped end. Okay, if they ask you propped end, then 3WL by 8. But such kind of, smart questions also they can ask you. And remember, in GATE, they won't be asking you lengthy question. They will be asking you conceptual short questions like this. And people who are smart and efficient and they know what is what, they will be able to solve in very fast manner. And other people will be writing research papers in the examination. Yes. So understood, this type of question we can easily solve. Another type of question is when the point load is not acting at the pre-end. Suppose it is acting at some other point, suppose midpoint. Okay. Suppose it is acting at a distance of A from the, it is acting at a distance of A from the fixed end. Suppose this is A. So this is A. Then this will be what? This will be L minus A, right? This will be how much? L minus A. You can solve this thing using moment area method also, other methods also. There are many methods. I am trying to do something simple things. Okay. See, there are many things, but we are trying to cover all the most important things here. Yes. So here, if you see, the deflected shape will be like this. And then what will happen? From here, it will be straight. Why? Because there is no bending here, right? The load is acting here. So bending moment will be only in this part. Here the bending moment is 0, na? Here the bending moment is 0, na? So there won't be any bending here. So this will be a straight. Here there will be no curve shape of the beam, right? So I can give, I can tell that, this is the point load acting, yes. And I can say that this deflection is suppose y1, right? And what will be y1 and slope here? Suppose theta 1, suppose this is the 1 point. Suppose this is the 1 point. So how to find out? Very easy. Take A as the length because it's acting at similar to what? Just think that it is the pre-end. Take A as the length. So I can say that your theta 1 will be equal to what? It's a point load. So PA square by 2EI. In place of PL square by 2EI, it will be what? PA square by 2EI. And this deflection at 1 will be how much? It is PAQ by 3EI. Very easy. Very easy. Okay. But how to find out at the free end? How to find out at the free end? Now see here, this is a straight, right? There is no bending happening in this portion. It is straight. So if this is straight, then at this 2 point, yes, this slope theta 2 will be equal to theta 1 only, right? Yes or no? If this is straight, then what I can say? This theta 1 will be equal to theta 2. See, if this was in a curve like this, see, this was in a curve like this slope and this slope would have been different, right? Yes, if suppose this curve like this. So this slope and this slope will be different, but it is straight, na? So what will happen? These two slopes will be same. So I can say that this theta 1 actually is what? Theta 2. Yes. Yes. So slope is same here. The slope is same here. Yes. But what about the deflection? Deflection won't be same. How to find out deflection? Very easy. What I will do, I will take this as y1 and take this as y2. Okay, and I can say that the deflection at free end is y1 plus y2. y1 we have already found out, right? y1 we have already found out. How to find out y2? Very easy. You take this triangle, take this triangle. Yes, this is what L minus A. I am taking this triangle, okay? This L minus A. This is theta 1 and this is what? y2. Can I say that tan theta 1 is equal to y2 by L minus A? Yes. And for small angles, you see this angle won't be very big. Here I have drawn very big because I am trying to explain. In deflection, beam doesn't bend like this. Okay. I have drawn here big to just show. In reality, the deflections and these angles will be very small. For small angles, this tan theta 1 will be equal to what? It will be equal to theta 1. So from here, what will be y2? y2 will be theta 1 into L minus A. Yes. So when I write this, y1 is how much? It is PAQ by 3EI. y2 is how much? y2 is theta 1. Theta 1 is how much? You see, PA square by 2EI. Then what? Then L minus A. Then L minus A. So when I find out this total deflection at the free end, what I will do? I can take PA square by EI common, right? Yes. I can take PA square by EI common. Then the first term is what? First term is A by 3. It is A by 3. And the second term is what? It is L minus A by 2 actually, right? It is L minus A by 2. Yes, game over. Yes. So now this will be equal to, you can see, PA square by, if I take LCM, it is 6. So 6 EI. Then I have taken LCM. So this will become 2A. And this will become what? 3L minus 3A. So this changes to what? 3L minus A. Game over. So this is the answer. 3L minus A. Yes. So this is what? The deflection at the free end. Okay. This is the deflection, the free end. Yes. When load is acting at a distance from the fixed end. Right. Load is acting at, and what is the deflection below load? Yes. Below load is very easy. It is what? Simply PAQ by 3EI. That is the Y1, right? That is the Y1, right? You see, below the load it is the Y1, right? You see, below the load it is Y1, right? Yes, remember these formulas, they can be asked. So they can frame a question simple like this. How many types of questions they can frame? You know, from the standard conclusions which I am telling, there will be lot of questions. Okay, lot of questions from standard things. Suppose the load is acting at L by 2, L by 2. Means at mid it is acting. And if I want to find out the deflection at the free end, okay, suppose slope at the free end. Slope at the free end is what I told. Slope at the free end remains what? Slope at the free end remains what? It remains whatever we get below the load also. Below the load also I'll get what? P A square by 2 EI, right? So I can say A is here how much? L by 2, na? Yes. A is here how much? L by 2, right? So it becomes what? P L square, then L by 2 square means 4, 8 EI, right? Yes. But if I'm interested in finding the deflection at the free end, it is what? The formula is PA square by 6 EI. Then what? 3L minus A. Right? 3L minus A. So what happens? This becomes, you see, it is L square by 4. So 24 EI, right? 24 EI. PL square by 24 EI, right? Yes, because L by 2, na? So L by 2, L by L square by 4, so forth. And then 3L minus L by 2. So what is 3L minus L by 2? It is 5L by 2, right? It is 5L by 2. So it becomes how much? 5L cube by 48 EI. 5L cube by 48. Yes, easy. So this I get, right? Yes, very easy. They can frame a question also like this, you see. They can frame a question like this, you see. They will tell that we have a cantilever beam like this. Yes, and we have a point load of 80 kilonewton acting at the mid. So it is 2 meter, it is 2 meter. But here we have a propped end. Ooh. So here we have what? A propped end. So if you have a propped end here, they can ask you what? Find out the reaction here. Yes, find out the reaction here. Now I cannot use this WL by 8 here, 3 WL by 8, because that is for a UDL thing, na? So what I will do here, very easy. What I will do? I will take the effect of this point load. Due to the effect of this point load, you see, like this, you see, the deflection at free end is how much? Okay, here I forgot P. The deflection is how much? It is 5 PL cube by 48 EI, right? And it is acting at the mid, right? Yes, here L is how much? 4 meter actually. And W is how much? P is how much? This. So due to this, at this point, yes, so the deflection is how much? 5 PL cube by what? Your 48 EI. And this should be equal to the upward deflection due to reaction R, which is what? RL cube by 3 EI. Yes. So from here, what is the reaction we will get? The reaction we will get is 5 P upon 16, right? I'll get what? 5 P upon 16. And this is how much? 5. P is 80 and then divide by 16. So how much you get? 25 kilonewton. Yes. So you see, if you are smart like this, then you can solve many questions of deflection of beams within 1 minute actually, right? Within 1 minute you can solve many questions if you know what is what. Otherwise you can just go on doing research. If this is 25 in this question, right, then this will become how much? 80. So this will be 55 Newton, right? You see? Yes, you can ask a question like this. Yes, easily you can solve, right? Okay. Now, okay. Now one homework question I will give you. Okay. One homework question I will give you. Okay. So, suppose if we have a propped cantilever, okay, if we have a propped cantilever like this, yes, if we have a propped cantilever like this, but load is not acting at the center, it is acting at L by 3. So here A becomes what? L by 3. Yes, and this will be obviously 2L by 3. So in this case, what is the reaction? This will be some in terms of P, and this is your homework. Okay. So this is your homework. Okay. So you have to find out that R reaction. It will not be, it cannot be 5 P by 16, but it's not acting at the center, right? Okay. So use this and solve this question. I try to cover all the most important things. Okay, so first we saw moment area method. Okay, yes. Then we saw the application in cantilever beams, and all the standard cases can be asked. 4 standard cases are there. I derived the slope and deflection for all standard cases and also solved the types of question they're asking. Also we saw for simply support beam. Okay, there are deflections in your structures also. In structures we see what? Indeterminate beams. These are for determinate beams, I have found out. And also we saw the types of questions they can ask for what? Propped cantilever beams. So there is deflection in your structures also, or I can say structural analysis, where we see indeterminate beams. Okay, even you see propped cantilever is an indeterminate beam actually, but by using the deflection concept we are able to find out the reaction. So therefore I tried to cover that also. So that homework question is given, so please try to solve that, and thank you very much for attending. Yes, thank you very much.